welcome to True Projects. In this video, we are going to explain about the project which is medicinal plant classification using particle swarm optimized cascaded network. Before getting into the execution, first let us understand what is the project about. So this is the world where almost everyone, that is every medicine we take from pain relievers to life-saving treatments has its roots in plants. So that's how crucial medicinal plants are. In fact, many modern drugs that we take, like aspirin, that is from willow bark, and morphine, that is from opium poppy, trace their origins to nature. There are over 350,000 species of medicinal plants on the planet, and these plants are vital to healthcare systems worldwide. However, as vital as they are, identifying these plants accurately is not easy task. Traditionally, so we do have some traditional methods. That traditional methods rely on experts who visually examine plants looking at the factors like leaf, shape, color, and the texture. While this approach has worked for centuries, it is time consuming and also subject to human error. Imagine trying to identify hundreds of plants in a day. One wrong identification could lead to dangerous consequences, especially in medicine where precision is everything. Plus, the availability of experts is limited and the process becomes impractical when demand rises. Given that global demand for medicinal plants is growing rapidly, especially as more people turn to plant based medicines, there is an urgent need for more efficient, reliable ways to identify these plants. As we continue to explore their potential in drug discovery and healthcare, automated plant identification systems are becoming crucial. So that's where the modern AI and machine learning comes in, providing much needed solution to this challenge. Moving on, when it comes to automated plant identification, that is plant classification, most of the existing methods rely on close up of images of a single leaf. These systems are designed to work under very specific conditions, like using the same type of camera, capturing the image from a short distance. While this approach might work in controlled environments, it has lot of limitations when it is applied in the real world scenarios. For example, if you might take picture of a plant from a different angle or using a different smartphone, the system might not recognize it correctly. The other big issue is that many of these systems require a lot of computational power. This means they can't easily run on devices like smartphones, which are more accessible for people in remote areas or on the go situations. Plus, many methods require the images to be processed on a powerful computer away from where the plants are located. This makes them impractical for real time on site use, especially in the field work or environments where quick decisions are needed. So while these methods can work in control settings, they don't offer the flexibility, speed, or accessibility needed for practical use. So to overcome all these issues, we have developed a system that is designed to make plant identification easier and more accurate, which has been using the smartphone images. So in this project, we have loaded the data set from the open source, and that data set has been captured. I mean, that images are captured using smartphone that are taken right at the site where the plants grow. Instead of relying on the traditional method of expert observation, which can be time consuming and prone to error, our system leverages advanced technology to classify medicinal plants efficiently. And in this project, we have incorporated the pre-trained ResNet 50 convolutional neural network model, that is the deep learning model that has been trained on the massive amount of data, allowing it to extract and select the important features from the images such as shape, texture, and color that are essential for identifying the plants. To make the system more efficient, we have incorporated particle swarm optimization. It's a technique that helps to select the most important features, cutting down the unnecessary data and speeding up the process. Once we have optimized the features, we use support vector machine to classify plants into seven different classes that are nothing but aloe vera, henna, hibiscus, holy basil, lemongrass, mint, and neem. So the system has been thoroughly tested using several performance metrics that are nothing but accuracy, precision, recall, and FN score and robustness. So this ensures that it works well across different environmental conditions, making it reliable for the use. Moving on, to further improve the performance, we have fine-tuned the SVM model as the extension. So here we have taken the SPM algorithm and we have fine-tuned it with different parameters to boost its performance. So this adjustments has resulted even better accuracy than the original system, making it more reliable when identifying the medicinal plants. But we didn't stop here. We have developed front-end using Flask framework. So we have developed front-end using Flask framework to make the system more user-friendly and accessible. This allows users to interact with the system directly from their devices, makes it easy for them to upload images and classify medicinal plants. To ensure to ensure that the only authorized users can access the system, we include user authentication, adding an extra layer of the security. So this front-end extension will not only make the system more practical for everyday use, but also provide hands-on way for users to test the system capabilities and see how well it performs in different scenarios. So this is about theoretical part. So here the first step that we have implemented is we have imported the packages. So first we have imported all the necessary libraries and packages required for data processing, machine learning, and building the web application. Then before diving into the model's building process, it is essential to explore and understand the dataset. So this involves checking the structure, data types, and inspecting some sample data to ensure everything is correctly formatted. And then we have visualized the data set. We visualize the data set that helps to identify patterns, outliers, and potential issues. Here we plot graphs to better understand the distribution of the data and relationship between plant classes. The next step is image processing. Here images are resized to a consistent shape for easier processing to reduce computational load. And then the images are slightly skewed to help the model learn to recognize the plant from different perspectives. So we do shear transformation. And then we random we randomly zoom in the images. So we random zooming is applied to the images to make the model more robust to various scales. And then images are flipped horizontally to add variety and teach the model to identify patterns in mirrored orientations. Then images are reshaped to fit the input size of the neural network. The next step is feature selection using ResNet 50 convolutional CNN. So here we have used pre-trained ResNet 50 model to extract high-level features from the images. So ResNet 50 is a powerful deep learning model known for its ability to recognize complex patterns in images. The next step is feature optimization using PSO. Particle swarm optimization is used to optimize the selected features by identifying most relevant ones, improving efficiency and accuracy in the classification process. Then the features X and the label Y are separated. X labels the input images and Y represents the corresponding plant classes. Coming to splitting the dataset, here the dataset is split into training and testing sets. Training set is used to train the models and testing set is used to evaluate the model's performance on unseen data. Coming to next step, that is here a classification model is built using selected features and labels. Here we have developed support vector machine and other base learning models. In the next step, the model is trained on the training data, allowing it to learn patterns and relationship between the input features and plant classes. Coming to the next step, various metrics that are accuracy, precision, recall, and F1 score are calculated to evaluate model's performance. Then we have compared them using the graphs. And coming to the front end part, a user-friendly interface is created using Flask where users can interact with the system. The interface includes options for registration, login, and managing user input. And in the front end users, they will be able to upload the medicinal images and that will be pre-processed at the back end. It will be fed with the train model. Finally, outcome will be displayed through front end by classifying which type of medicinal plant it is. Coming to the algorithms used, these are the algorithms that are used in the project. So this is the proposed one, and these are the base models used for comparison, and this is the extension model, and extension model has achieved the highest accuracy. Coming to requirements, to implement this project, we need basic requirements which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let's execute. To execute, we need to open the code folder that contains source code files. So these are the source code files in the code folder of the project. Let us understand them. How will they be used in the project? Coming to dataset folder, let us open it. So these are the 7 different types of medicinal plants that are used to train the project. So these here in this folders, we have the images. Let us open the aloe vera folder. So these are the images of aloe vera that we will be using to train the model so that they will be able to classify the aloe vera medicinal plant. Similarly, we have henna images. So these are the images related to henna medicinal plant. We do have hibiscus images. So these are the hibiscus images. And we do have holy basil images. So these are the holy basil images. We have lemongrass images. We have mint images. And we do have neem images. So these are all the medicinal plants. These are all the medicinal plant images that are used to train the all the algorithms that are built in the project. And here in the model folder, we have the algorithm information that will be loaded into the project code during runtime. And they are saved in .h5, numpy, and pickle files. Coming to static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in the test images, we have some of the images that we will be using in the front end to classify the medicinal plants. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook file. This is the notebook file, which is a Jupyter notebook file. This contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file which is used to store the user information. So now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt. It has been opened. Now use the command cd, give the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folders path. So by giving cd command, it will change the code folders, current directory to the code folders path. Now we have to compile the app.py file. So give the command python space app.py. Now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So this is the local host and this is the port. Now we have to copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to sign up first. Click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Give your username and the password. Click on sign in. We have signed in successfully and we are redirected to classification page of the project. So here you can see choose file button, right? We need to click on that for uploading the medicinal plant images. Click on that. So here, this is the sample folder where we will be using these images as test cases. Let us upload the first image and see what will be predicted. Click on upload. And the given image will be pre-processed at the backend and then train model will be giving us a prediction. So this is the uploaded image and here it has given the prediction as aloe vera. So it is giving the prediction as aloe vera. Now let's upload one more image. Click on choose file. So now let's upload the second image. Click on open and now upload it. So based on the uploaded image, here we got the prediction as henna. If you look at the image, you can observe that this is the henna plant, right? So application is also correctly predicting it as henna plant. That is the medicinal plant. Now let us upload this image. So we are uploading hibiscus plant. Let's check whether application will correctly predict or not. So see here, application is correctly predicting the hibiscus plant. So this is the image that we have uploaded. And here we have the correct prediction. Let's upload some more. Click on classification. So now let's upload this one. Click on upload. So this is the uploaded one, which is the lemongrass. And here we got the correct prediction as lemongrass. Let's upload one more. So now let's upload this image. Click on open and now upload it. So this is the image that we have uploaded and here we got the correct prediction, that is holy basil. Let us upload some more images and see whether it will correctly predict it or not. Now let's upload this one. So here we got the prediction that neem is detected. So here if you observe, this is the neem plant, right? So application is also correctly predicting it as neem plant. Let us upload some more. So let's upload this one. Click on upload. And here we got the prediction that mint has been detected. So far, you have observed that we have detected hibiscus, mint, holy basil, and also other plant that are medicinal plants. So this is how we need to upload the images. Then we will be getting the medicinal plant classification. That is which type of medicinal plant it is. Now let's check with the graphs. Click on graph. So this is the confusion matrix of the extension model. So here on x-axis we have predicted class, and on y-axis we have the actual classes that are nothing but true classes. Here in the diagonal, those are the actual predictions, and above the diagonal and below the diagonal are the misclassifications. Here, if you observe, there are very few misclassifications. This shows that the model is accurately performing, that is accurately classifying the medicinal plants. And this is the accuracy comparison graph. Here on x-axis we have the accuracy score, and on y-axis we have all the algorithms that are built for classifying the medicinal plants. And here we have precision comparison graph. This is recall comparison graph, and this is FN score comparison graph. Now let's log out. Click on sign out. In this switches by uploading images to the application, then the application will feed the data set to the train model, and the train model will be giving us the prediction, that is which type of medicinal plant it is. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.